right, welcome back, guys, to part 2 of Wednesday's asynchronous lesson. We are moving on to the next section, 513. We finished 512, yay. And in this section, we're going to learn what can I do with inverses. More inverse functions, yay, just what you always wanted. This is problem 39. You can write it down. We're going to have this table right here, x and f of x, which is y. Fancy way of saying y. 1, 3, 5, 7 for our x's, -5, 7, 19, and 31 for our y values. Part A, write an equation for the function represented in the table at the right. So we can see that these numbers are going up, and to find out what they're going up by, take like the two easiest numbers, 19 and 7, and subtract them, and we'll get 12. So let's see, does this go up by 12? If I take -5 plus 12, do I get 7? 7 plus 12 is 19. 19 plus 12 is 31. Yes, that seems to be the pattern. So the equation that we would want, y, it's going to be some linear equation, some y equals mx plus b. Well, our slope is our rate of growth, which is 12. It's growing by 12 every time. So y equals 12x. And then our b value is what 0 would be. So what is the value of 0? Well, it's going up 12 for every two numbers, because you notice these are going by 2. So if I only want to go back 1, I'm not going back to -1. I'm not going back 2. I'm going to go half as much. So I'm going to go back 6. So I want to take -5, the 0 term, and I want to minus 6 from that, which gives me -11. So -11. So 0, -11 would be the term before 1. Okay. Oh, you know what? And I messed up. This isn't 12x. It's 12 divided by 2, because they are going up by 12 for every 2. So we have to do 12 divided by 2, which is 6. So good thing I looked at my notes there and I caught that. So let's erase that and make that 6x. Draw tool, 6x minus 11. That's the actual equation. And you should test this to make sure it works, right? So if I plug in 5, I should get 19. So y equals 6 times 5 minus 11, which is 30 minus 11, which is indeed 19. So, you want to test out your equation, because if I would have used 12x minus 11, I wouldn't have got 19 when I plugged in 5. That would have told me my equation was wrong. All right, so you want to spot your errors. Make a table for the inverse. How is the table for the inverse related to the original function? Well, hopefully you know this by now, because we've done this quite a few times. If I make a table for the inverse, this is going to be my x, this is going to be my y, and we're just going to flip them around. So we're going to flip the numbers around. So my y's are going to be my x's, -5, going to go up to 7, up to 19, up to 31. Then my y's are going by 2, starting with 1, 3, 5, and 7. Your odd numbers right there, adding 2 every time. So that's what the table for the inverse should look like. This is for the inverse, right? Which we can say is f -1 of x, or f inverse of x is how we write that. So the original function is f of x, and then f inverse of x is like this. They're related because their values are backwards. The x and y are switched, right? X and y values are switched. Okay, that's just a review. We've done that before. Write an equation for the inverse function. Okay, so this is a review too. How do you get an equation? Well, we have this equation for our inverse. This is our f of x equation, right? 6x minus 11. So we want to switch this around. So this is my y value. So I'm going to put x equals 6y minus 11. So you switch your x and y, and then you solve for y. So we're going to add 11 to both sides. This is where we work backwards and we undo a bunch of stuff, because the inverse is just undoing the original function. And then divide by 6. So that is our inverse function right here. F inverse of x is equal to x plus 11 divided by 6. That is the inverse function. That was just a big review problem. So hopefully that is just pretty easy for you. We're going to move on to the next problem. That was 39. Got to clear this out. And go to the next slide here, which is number 40. Write the inverse function of the following functions. Clearly show all your steps. Well, I don't have B on here. I'll go ahead and write B, but here is A. We'll start with that. So for A, we have, so this is our function, y equals 2 times x minus 1 cubed, right? This is a cubic equation. If I were to graph this, I'd get like something like this, right? So, but it'd be shifted over 1 unit, and then it would be wider because it's a 2, and the cubics go like that. It's positive, so it's going to go in that direction as opposed to going in this direction if it were negative. Okay, so we know a lot of things about that, right? The inverse function of the, so to find the inverse of this, we're going to switch the x and the y. X equals 2 times y minus 1 cubed. This is the inverse function, but we need to solve it for y. So let's go ahead and work outside in, take away the 2 first by dividing by 2. Okay, so we're going to divide by 2 and get x over 2 is equal to y minus 1 cubed. Now, to get rid of the cubed, we're going to take the cube root. So we put a little 3 here. We're going to take the cube root of x over 2. Okay, and that gives me y minus 1 equals the cube root of x divided by 2. And lastly, we are going to add 1 to this whole thing. So when I add 1 to this whole thing, it does not go underneath the cube root, okay? So it's cube root of x over 2 plus 1 outside. So that shifts everything up. It's going to move this whole graph up 1 unit, right? Is what that plus 1 does, equals y. Or instead of y, I'll put f inverse of x. That's a better notation because that tells me, oh, that's the inverse, not the original function. So if I just put y, I can't really tell if that's the original or the inverse, but this tells me this is the inverse. So this, the cube root of x over 2, is the inverse of x cubed. And that makes sense, right? The opposite function of cubing something is taking the cube root. So the inverse should have a cube root if the original function has a cube in it. Okay, now B. Let me write B down, and I have to erase this to make room right here. I forgot to copy B on here. So B in your book says, hopefully I copied this down right. Y, or f of x, I'm not sure, I'm looking at my notes. So f of x equals 3 times x minus 9 over 2 parentheses plus 20, a quantity plus 20. Okay, so we want to find the inverse of this function. So this is my y value. So I want to switch the x and the y first. So x equals 3 times y minus 9 over 2 plus 20. So we need to undo all these numbers and get the y by itself. Solve for y, right? We have to solve for y after we switch the x and y. First you switch x and y, and then you solve for y. Okay, so let's get rid of the 20 first. You have to get rid of the 20 and work your way outside in, furthest away from the y. Okay, so we minus the 20. The 20 is furthest away from the y, so we do that first. So we have x minus 20 equals 3 times y minus 9 divided by 2. Then I want to get rid of this 3 by dividing by 3. So I'd like divide by 3, divide by 3, that goes away. And we get y minus 9 equals x minus 20 divided by 3. And then we add 9, add 9. So instead of y, I'm going to put f inverse of x, because this is the inverse, is equal to x minus 20 divided by 3 plus 9. The 9 is not with that. You add 9 afterwards, because what that's going to do is going to, so if this is a line, which it is some line, it's going to shift it up 9 units. So it's going to go up 9 units, right? That plus 9 is going to do that. This is shifted up 9 units. This is shifted to the right 9 units, and this is shifted up 20 units. So their inverses are very different. Okay, and that is how you successfully work backwards. This is very algebraic. This is testing your order of operations. Do you know how to do algebra? Okay, and that is what makes the difference between a good mathematician and a bad mathematician, is someone who can or can't do algebra. So these are important skills that we're learning that you're going to continue to use in pre-calc and calculus. All right, so I think there was just a B, so I'm going to clear this out and then go to 41. Next slide. Last one that we're going to do for this video, because this is a doozy. Look at this. Actually, it's not that bad. It just looks intimidating. Adriana's strategy for checking that the functions f of x and f inverse of x are inverses of each other is to think of them as stacked function machines. So like this, right? She starts by choosing a number to drop into f of x. So it looks like she's choosing 3. She drops it in. Some number is going to come out. You know, let's say it's 15 or something like that. Let's say 15 comes out. Well, if she puts 15 back into the inverse function, shouldn't she get 3 back? Shouldn't she get what she started, right? If you start with the function, you get some number like 15, and then you put that output back into the inverse function, it should give you input that you originally put. Okay, so this makes sense, right? All right, so let's see what is next. With your team, select a pair of inverse functions from problem 40, then use Adriana's ideas to test them. Okay, so this is problem 41. I think I just used the first equation. I chose to use the first equation, so I'm going to write that down. So for part A, let's use the first equation, which is f of x equals x minus 3 squared plus 2. And we'll shift it up 2 units. So this was the first equation. So let's plug in 3 into her function since she picked 3. F of 3 equals 3 minus 3 squared. Maybe this is why she picked 3, because when you do 3 minus 3, you get 0 squared plus 2, which is just 2. So f of 3 is 2. Okay, when you plug in 3 into this function machine, you get a 2 that comes out. So if I plug in 2 to the inverse function, I should get 3 back. Okay, an f inverse. And our inverse function, check what that was. This thing is in my way. What was our inverse function? Did we find the inverse of this? I think we did. And okay, so the inverse was f inverse of x was the square root of x minus 2 plus 3. Okay, that was the inverse function. So if I put in here, if I plug in 2 into this, the output of our function, we should get 3. Let's see. So 2 minus 2 square root plus 3. 2 minus 2, that's 0 plus 3. We get 3. We do get 3. So when we plug in the output that we got from the last function, we plug it into the inverse, we got what we originally plugged in, 3. So we dropped in 3, we got a 2, we put it into the inverse function, and we got 3 back. So this tells us that, yes, these two functions are inverses of each other. Okay, why would we want to do this? To test if these two functions are inverses of each other. So this kind of tells us, yeah, this function and this function are inverses of each other. Okay, because they worked. Okay, that is A. B. Adriana wants to show her work algebraically. She knows that if she chooses her input for f of x to be 3, she can write the output as f of 3. Next, f of 3 becomes the input for f inverse of 3, and her output is 3. Since f of 3 is the new input for f inverse of x, she thinks that she can write this process as f inverse of f of 3 equals 3. Okay, take a look at that. F inverse of f of 3 equals 3. Does her idea make sense? Why or why not? So she wants to write f inverse of f of 3 equals 3. So we always start from the inside out, right? So f of 3 means the value that you get when you plug in 3 into this function, which would be 2. So f of 3 would be 2. And when I plug in f inverse, when I plug in 2 into the inverse function, am I going to get 3 back? And the answer is yes. So you can absolutely write what she wrote, which essentially is this: f inverse of f of x equals whatever x is that you plugged in. So if I take the original function and I plug it inside the inverse function, I'm going to get whatever value I plugged in for x. I'm going to get x, essentially, is what this boils down to. So yes, this is true. Yes, this makes sense. Okay, a little confusing, but it absolutely is true. Okay, so C, does Adriana's strategy confirm the functions are inverses of each other? Is there anything else she should check? Yeah, because we plugged in the numbers and we got, and if we did this, you know, we plug in f of 3, we got 2, plug in inverse of, plug in 2 to the inverse function and we get 3. So yes, this makes sense. Yes, just gonna put yes for that. D, use your strategy from part C to confirm that f of x is the inverse of f inverse of x. Write an equation that expresses your results algebraically using the notation from part B. So this is part D. To look for my work for this. Use your strategy from part C to, okay, I know what they want us to do here. So I'm going to erase some of this. I didn't catch this the first time, but now I understand what they're asking us to do. So I'm going to erase the part where we plugged in numbers. I just want the original functions. Okay, so if we take this function, right, f inverse of x. So this is the function we're using. F inverse of f of x, right? F inverse of x of x. This means I'm plugging f of x into f inverse of x. Okay, so this is f inverse of x. So I want to plug this function into this function. How do you plug one function into another function? This is super important. This is called taking the composition of two functions. This is what you're doing on the second half of the worksheet that I assigned for homework. Odds only. Okay, so I want to plug this function into this function. Well, you plug it in wherever there's an x, you're going to plug in this whole thing right here, substitution, okay? So f inverse of f of x, if I plug one function into the other function, this is what it's going to be. It's going to be the square root of x minus 2. Well, this is what f of x is. This is what x is. It's f of x. So we're going to plug in that whole function for x. X minus 3 squared plus 2. And then there's always going to be this like opposite minus 2, because this is going to have a plus 2 and that's going to have a minus 2. And they're always going to be opposite like that because they're inverse functions of each other. And don't forget the plus 3 at the end. Okay, so look what we did. We plugged in this function into this whole function right here, plugging one whole function into another function, and then we evaluate it. So if I evaluate this, well, these are going to go away. That's just 0, right? So that's 0. So then I get x minus 3 squared times the square root of that. plus 3 on the outside. Well, a square and a square root cancel each other out, so that's gone. So now we just have x minus 3 plus 3. And then the minus 3 and plus 3 cancel out. So we just get x. So when we do f inverse of f of x, whenever you plug in the original function into the inverse function, you should always get x, okay? And you have to show this work. And it can't just be one step. And it can't just be, oh, you plugged it in and you got x. Like this is the work I'm looking for. If you don't have this work in your work, then you're not going to get credit. You can't just put x because you know it has to be x, okay? So, and the reverse is true also. Is that what we're going to say in the next part? Will this strategy for testing inverses work with any input? And that's true. Yeah, any input. So if I put like 5 in here, if I do f inverse of f of 5, you're going to get 5, right? That's what the x value is. If I do f inverse of f of 8, then you're going to get 8. Okay, this x is going to equal that x, okay, every time. But the important part of this is learning to plug in one function into another function. And the reverse is going to be true too. I don't know if we talk about that later, but f inverse of x, oh, that's a -1, f inverse is also x. But right now we want to put the original function into the inverse, or you could do vice versa and it's still going to be x. Okay, so that is like a heavy duty concept right there. That's important. And we'll be doing more of this in the next portion of this video, but this is going to be the end of this part of the video. All right.